Given that there is an object traveling along on a horizontal path, and we could view it as perhaps being a little cart, and we are told its initial velocity is 2 meters per second. So v0 equals 2 meters per second. And we're given its position time. And then we're asked to evaluate the graph of its velocity as a function of time. Well, what we might employ then is to use our average velocity formula, which is delta x over delta t. And we could figure out what the average velocity is during this first interval, in the first second. So delta x over delta t is the average velocity for that interval, and we have a delta x 3 minus 0 over 1, which is 3 meters per second. And if we look at the second interval of time, the average velocity, delta x over delta t, is 8 minus 3 over 1 second, which is 5 meters per second. So we can see that the speed is increasing. And we look at the third interval time, the average velocity, delta x over delta t, is 15 minus 8 over 1, which is 7 meters per second. And you might take note that the change among these is 2. All right, so now we're looking at the graphs. We want to evaluate these graphs. And the first thing to do when we ever have a graph is determine the 3 quantities, the things we can read, which are velocity and time, the slope, which is delta v over delta t, and that is the definition of acceleration. So the slope is the acceleration. The area, which is v delta t, meters per second times seconds, gives us units of meters. So that means that the area is telling us the displacement. And of course, we want to remember what's going on with the y-intercept. For a velocity graph, v0 equals 2 meters per second. So that's the first criterion we can use for any one of these graphs. We could determine whether or not the initial velocity is 2 meters per second. And we see here on the first one, yes, it's 2 meters per second, 2 meters per second, 2 meters per second, and 2 meters per second. So the y-intercept, which sometimes is helpful to us, isn't going to help us here. The next thing we want to see is that the velocity is increasing. So if we look at this first choice, the velocity remains 2, so that is out as a possibility. It says the velocity remains the same. We look at the other 3, and we see that the velocity is changing, generally increasing. Now, if we look at what it increases to at the end of 3 seconds, this one says that the velocity is about 17 meters per second. It says this one is about 9 meters per second. And this one, it says, is 8 meters per second. So if we look at the choices we have here, it's really hard to get to 17 meters per second. So this one's going to be out. The next thing we might determine is use this information about the slope. The acceleration is the change in velocity over the change in time. Well, if we look at the numbers we had here, if the acceleration is the change in velocity over the change in time, well, during this interval, we went from 3 to 5. So 5 minus 3 over 1 second is 2 meters per second squared. And if we look at it this next interval in time, we have 7 minus 5 over 1, which is 2 meters per second squared. So what that tells us is it looks like the acceleration is constant. And the acceleration is the slope. We're looking for constant slope. We look at choice 2, it looks like constant slope. Choice 4 is not constant slope. So that tells us that choice 2 is definitely the best answer. Now you may be wondering about this final velocity that was 8 meters per second when we had an average velocity of 7. When something is accelerating, so during this interval of time of 2 to 3 seconds, what we're saying is that the average velocity was 7. So if during that whole time the velocity was 7, that would produce the same change in position as a constantly increasing. In other words, if we're looking at the displacement, which is the area underneath the red curve is equal to the area underneath the green curve. So they're producing the same change in position. In any case, it's pretty easy to get to the final answer, but we can see why it didn't give us a final velocity of 7. It gave us 8 instead because it started at a lower velocity. It was accelerating the entire time.